made it back. Welcome to our universe. This place was here before you arrived. It doesn't need you to be complete. But right now, I'm glad you're here. Maybe it's been a long day, the kind that pressed down from the moment it started, and you've been carrying it in your shoulders, your jaw, somewhere behind your eyes. You can put it down now. Or maybe you're the kind of person who finds themselves looking up at the sky on ordinary evenings, not because they're searching for anything specific, just because something out there pulls on you, quiet and persistent, like a tide. Either way, you found your way here. That's what matters. There's nothing you need to do now but rest. Nothing to carry into tomorrow. Whatever drifts by tonight is allowed to drift away again. The universe doesn't require witnesses. Let your weight settle. You're being held by a planet moving through space at 30 kilometers per second. You won't feel it, but it's happening. Tonight, we'll travel. Slowly, gently, past the moon, past the planets, through fields of ice and the long dark beyond the sun's reach, past the edge of what the sun still holds, and then a little further still. If this feels like your kind of place, subscribe. Every person who finds their way here makes this universe a little more ours, because this universe has always been yours. Let's begin. The distance to the moon is something your body can feel. The average distance from Earth to the moon is 384,400 kilometers. Written as a number, it resists the imagination. But unfold it this way. If you drove at highway speed, without stopping, without sleep, it would take roughly 5 months to arrive, one way. The moon moves, not randomly, but with the patient deliberateness of something that has been doing this for 4.5 billion years. It orbits. It pulls. It was present when the first cells in shallow oceans felt the tidal drag for the first time, moved by something they had no structure yet to name. That pull is still happening. Right now, as you lie still, the water in your body is experiencing the same tidal force the early oceans did. Immeasurably small, detectable only by instruments far more sensitive than feeling. But the math is real. Every tide that ever reshaped a shore, every current that ever carried a creature to warmer or colder water, every slow change in coastline over millions of years, all downstream from that same faint tug, the same one that is in the room with you tonight. Light from the sun arrives 8 minutes late. Sunlight takes approximately 8 minutes and 20 seconds to travel from the surface of the sun to the surface of the earth. This is not a metaphor for anything. It is a statement about physics. When we observe the sun, we observe it as it was 8 minutes ago. We have never seen the sun as it is right now. No instrument has ever captured that. By the time any signal, light, radio, anything moving at the maximum speed the universe allows, reaches us, the sun has already continued. What we have is a permanent delay. The planets orbit a sun they are always seeing slightly in the past. Jupiter sees it as it was 43 minutes ago. Saturn, 79 minutes. Neptune receives sunlight 4 hours old. Pluto, as old as 5.5 hours. Voyager 1, now in interstellar space,
receives a signal from Earth that left more than 22 hours earlier. Everything we know about the universe is old news. We have never seen the present.
Mars keeps a record of every impact it has ever survived. Imagine a surface so still that it hasn't changed in 3 billion years. No wind strong enough to erase a mark. No rain. No roots reaching up through the ground to soften an edge. Just a crater, exactly as the impact left it, sitting under a salmon-colored sky with no one to observe it. Mars is covered in craters. More of them preserved more completely than any other planet we have visited with instruments. Some of them are older than any rock you've ever touched, older than the continents, older than the oceans that carved them. The largest is called Hellas Planitia, a basin nearly 2,300 kilometers wide, 7 kilometers deep, still holding, still intact, still recording an event that happened before Earth had a moon. Mars is not a dead planet. It's a patient one, a record keeper. Every scar on its surface is a timestamp from the early solar system, the period before things calmed down, before the bombardment slowed and the inner planets grew quieter. If you wanted to read that era directly, not in books, not in models, but in geography, Mars is one of the clearest texts we have. Older than the continents, older than the oceans, older than the oldest memory any rock on Earth still carries. The asteroid belt is mostly silence. The asteroid belt between Mars and Jupiter contains roughly 1 to 2 million asteroids larger than 1 kilometer across. If you flew through it, you probably wouldn't notice. This surprises people. The images we see in films, dense fields of tumbling rock, narrowly missed by spacecraft threading through them at speed, are a fiction of visual storytelling. The actual belt is almost entirely empty. The average distance between asteroids is roughly 1 million kilometers. If you placed yourself at a random point inside the belt, you would most likely see nothing. The nearest neighbor, invisible at that distance. All those asteroids, scattered across a band 550 million kilometers wide, add up to a total mass smaller than the moon. They are the debris of something that never finished forming. Jupiter's gravity has been disrupting this region for 4.5 billion years, perturbing orbits, preventing accumulation, dispersing the pieces before they could gather into anything larger. There is no planet there. There never was. Just fragments, patient in the dark. Jupiter's magnetic field reaches past Saturn. Jupiter's magnetic field is the largest structure in the solar system. Not the largest planet, the largest magnetic structure. A region called the magnetosphere that extends roughly 7 million kilometers toward the Sun and stretches more than 1 billion kilometers in the opposite direction, deep into the outer solar system. If we could see it with our eyes, it would appear larger in the sky than the full moon. Not slightly larger, several times larger. The field is generated by an ocean of metallic hydrogen inside Jupiter, a state of matter that doesn't exist naturally anywhere on Earth. Under extreme pressure, hydrogen compresses until its electrons move freely, like liquid metal. An internal dynamo, spinning, generating a magnetic influence across a volume of space so vast that smaller worlds pass through it like fish through water. Saturn's orbit sometimes moves through the outer edge of this field. We live in a solar system with an enormous structure we cannot see. Right now, somewhere in the dark beyond the inner planets, Saturn may be drifting through another planet's magnetic wake, silently, without witnesses, and it will continue whether or not anyone, anywhere, knows. Saturn is less dense than water. If you had a body of water large enough, a basin the size of a small world, Saturn would float in it. Its average density is 687 kilograms per cubic meter. Water is 1,000. Saturn sits well below that line by a significant margin because of what it fundamentally is. Mostly hydrogen and helium, the lightest elements in existence, gathered by gravity into a sphere 95 times the mass of Earth, and yet distributed through that enormous volume, lighter than the sea. The rings are something else, mostly water ice, particles ranging from the size of a grain of sand to the size of a house, orbiting in a sheet so thin relative to its width that if you scaled the rings to the diameter of a piece of paper, the rings themselves would be thinner than the paper, about 20 meters thick, about 280,000 kilometers wide, a structure both too delicate and too vast to hold in mind simultaneously. We're not certain how old the rings are, somewhere between 10 million and 100 million years. Young in geological terms. The dinosaurs may have still been walking when Saturn's rings formed. We're still working out the details. Uranus was knocked over by something we've never found. Uranus rotates on its side, not slightly tilted the way Earth is, 23 degrees, just enough to give us seasons. Uranus is tilted 97.77 degrees. It essentially rolls along its orbit on its side, poles facing the sun in alternation. 42 years of continuous sunlight for one pole, then 42 years of continuous night. The most accepted explanation, something enormous, an object roughly the size of Earth, possibly larger, struck Uranus during the early formation of the solar system and knocked it over permanently. That object is gone. We have found no trace of it. It may have been absorbed into Uranus, or shattered and scattered across the system, or continued on a trajectory that no longer intersects anything we can detect. We don't know. What we do know is that the collision was permanent. Uranus has been rotating sideways ever since. Its moon's orbit around its tilted equator, also tilted, a planet and its entire system of satellites, recalibrated by a single event, and we cannot say with certainty what caused it, or where that cause went afterward. We have the angle, we have the effect. That's all we have. Neptune was found by prediction alone. There's a particular experience when you sense that something is affecting you, pulling on you in a direction you can't quite identify, and you cannot see the source. After Uranus was discovered in 1781, astronomers tracked it carefully. They measured its position against the sky year after year and noticed something. Uranus was not quite where the mathematics said it should be. Something was tugging at it, slightly, consistently, an invisible influence redirecting an orbit just enough to create a measurable discrepancy. Two mathematicians, Urbain Le Verrier in France and John Couch Adams in England, working separately without coordination, calculated where the source of that pull must be. Not by looking through a telescope, by working through equations, by reasoning backward from a consequence to a cause. Leverrier sent his predicted position to the Berlin Observatory. Johann Galle aimed a telescope at the calculated coordinates. Neptune was there, within 1 degree of where the mathematics had placed it. A planet located by the disturbance it created in the orbit of something else. Discovered before it was seen. Found as a shadow before it was found as a world. The Kuiper Belt holds the most unaltered material in the solar system. Beyond Neptune, beginning around 30 astronomical units from the Sun and extending to roughly 50, lies a belt of icy objects, smaller than planets, slower to form, spared the intense heat and gravitational sculpting of the inner system during the period when everything was still sorting itself out. The Kuiper Belt is cold, around negative 220 degrees Celsius. At those temperatures, chemical processes slow to nearly nothing. Material that formed here in the early solar system has changed very little in 4.5 billion years. Pluto is one of the largest bodies here, so are Eris, Makemake, Haumea, worlds most people have never heard of, orbiting slowly in the quiet and the dim. The Kuiper Belt is not the edge of the solar system, not even close, but it may be the most accurate record we have of what this system looked like in the first few million years after the Sun first ignited. No visitors since the beginning. Pluto has nitrogen snow and an atmosphere that disappears in winter. Pluto has an atmosphere. When New Horizons flew past in 2015, it detected a thin veil of nitrogen gas extending roughly 1,600 kilometers above the surface. Not breathable, not stable, but present. That atmosphere isn't permanent. As Pluto moves along its highly elliptical orbit and drifts further from the Sun, the temperature drops enough that nitrogen begins to freeze out of the air entirely, falling as snow, settling on the surface, disappearing into the ground until the centuries-long return toward the Sun brings warmth enough to sublimate it back into gas. The heart-shaped feature in the New Horizons images, Tombaugh Regio, is a vast plain of nitrogen ice, regularly renewed by this cycle of freezing and return. A surface that inhales and exhales on a rhythm measured in centuries. Pluto's year is 248 Earth years long. We happen to arrive during one of those brief windows when the atmosphere was present. It won't always be. When Pluto moves further from the Sun, the sky falls to the ground. And then, slowly, it rises again. The Sun breathes, and we live inside the breath. The heliosphere is the region of space dominated not by the Sun's light, but by its wind. A continuous stream of charged particles flowing outward in all directions at 400 to 800 kilometers per second. This stream inflates a bubble. The heliosphere is that bubble. At its outer edge, the heliopause, the solar wind weakens against the pressure of the interstellar medium, the material drifting between star systems. The heliopause sits roughly 120 astronomical units from the Sun, 120 times the Earth-Sun distance. A sphere of solar influence extending past Neptune, past Pluto, past the Kuiper Belt, into the outermost reaches of the system. Every planet in this solar system orbits not just around the Sun, but inside it, inside its warmth, inside its radiation, inside the wind it has been exhaling since before the first rock of this planet had cooled enough to hold shape. We are inside the sun's exhalation, right now. In this room, in these lungs, drawing in and releasing air without thinking about it. The planet carrying us through space at 30 kilometers per second, inside a breath that began at a star's surface and won't stop until exhausted by the sheer distance of space. The sun breathes. We live inside that. The solar wind can be felt as a faint pressure on spacecraft. Solar sails are a real technology. Photons, particles of light, carry momentum. When they strike a reflective surface, they impart a tiny force. Accumulate that force over weeks and months, and a spacecraft with a large enough sail can accelerate. Icaros, a Japanese spacecraft launched in 2010, successfully demonstrated solar sail propulsion in deep space. LightSail 2, launched in 2019, extended its orbit using only the pressure of sunlight. The force is extraordinarily small. The pressure of sunlight at Earth's distance from the sun is roughly 9 micronewtons per square meter, less than the weight of a few grains of salt pressing against a surface the size of a desk. And yet, it moves things. A persistent and gentle force, sustained over time, changes trajectories. Voyager 1 is the farthest human-made object that has ever existed. In 1977, engineers placed a golden record inside a spacecraft. The record contains greetings in 55 languages, music from Bach and Chuck Berry, and a Javanese gamelan. The sounds of surf, wind, rain, and whales. Encoded images, humans eating, running, a person nursing a child. A map to Earth drawn in pulsars, in case anyone ever needs to find us. The spacecraft is called Voyager 1. It is now more than 23 billion kilometers from Earth, in interstellar space, past the heliopause, past the solar wind, in the true space between stars. It crossed that boundary in 2012. It travels at roughly 17 kilometers per second. At that speed, it will take 40,000 years to come within 2 light years of another star system. The golden record is there right now, tonight, moving through material that has never been touched by anything made by human hands. The diffuse plasma of interstellar space, drifting between one star and the next. Almost certainly no one will find it, but it's still moving. The Oort Cloud has never been directly observed. We believe the Oort Cloud exists. The evidence is indirect. Comets arrive in our inner solar system from trajectories that imply a vast, spherical reservoir of icy objects at the very edge of the sun's gravitational reach, somewhere between 2,000 and 100,000 astronomical units away, nudged inward occasionally by the gravity of passing stars or by the subtle tidal pull of the galactic plane itself, falling toward the sun on orbits that take thousands or millions of years to complete. No spacecraft has come close to it. No telescope has imaged it. We infer its existence the way Neptune was first inferred, by consequences, by comets that arrive from nowhere, on orbits that require a source. If the Oort Cloud is real, and most evidence suggests it is, then the solar system extends nearly a quarter of the way to the nearest star, a vast shell of sleeping comets, held at the very edge of the sun's reach, waiting for something to disturb them. If it's real, we still don't know with certainty. And tonight, that's where we'll leave it. Between stars, there is almost nothing, and almost nothing is not nothing. The space between star systems is not empty. This is not meant to be reassuring. It is simply accurate. The interstellar medium contains gas, mostly hydrogen in various forms, along with dust, cosmic rays, magnetic fields, and the faint radiation from stars and supernova long since extinguished. The density is extraordinarily low. In some regions, roughly 1 atom per cubic centimeter. In others, less. 1 atom per cubic centimeter sounds like nothing. But a cubic centimeter is very small. Extend that density across volumes measured in light years, and the interstellar medium becomes one of the largest reservoirs of matter in the galaxy, constantly recycled, constantly in motion. This material was, at some earlier point, inside a star. Supernova scattered it. Gravity gathered it again. New stars formed, burned, scattered again. The same atoms, cycling through stellar interiors and the void between them, over and over across billions of years. There is no unused material in this galaxy. Everything is in transit. Every atom of oxygen in the air in this room has passed through at least one stellar interior, possibly several. The void between stars is not waiting to be filled. It has already been full, and emptied, and filled again, more times than any clock we have is old enough to count. Proxima Centauri has a planet in the habitable zone. The nearest star to our Sun is Proxima Centauri, 4.24 light-years away, a red dwarf, dim enough to be invisible to the naked eye despite being our closest stellar neighbor. In 2016, astronomers confirmed the presence of a planet orbiting Proxima Centauri in the habitable zone, the region where liquid water could theoretically exist on a surface. The planet is called Proxima Centauri b. We know almost nothing about it. We cannot see its surface. We cannot measure its atmosphere. We don't know whether it has water or bare rock or anything we would recognize. We know its minimum mass, roughly that of Earth, and its orbital period, approximately 11.2 Earth days. That's most of what we have. 4.24 light-years away. A light-year is approximately 9.46 trillion kilometers. No spacecraft currently built could reach it within a human lifetime. No signal we send tonight will arrive there for more than 4 years. The planet may have an ocean, or it may be a dry, irradiated surface, battered by the frequent flares of its young and active star, or something else entirely, for which we don't yet have a category. We have a name for it. We don't know what it is. We live inside a bubble carved by ancient explosions. The space within a few hundred light-years of the Sun has an unusual quality. The density of interstellar gas here is low. Stars are distributed with a certain spaciousness. There is, in the astronomical sense, a clearing. It has a name, the local bubble. Roughly 1,000 light-years across, it's a region of the interstellar medium that was hollowed out by supernovae, massive stars that lived fast and ended violently, blasting their material outward in expanding waves that cleared the gas and pushed it into the shell surrounding the bubble we now occupy. The estimates suggest between 15 and 20 supernovae contributed. The process is thought to have begun around 14 million years ago. The Sun didn't form inside the local bubble. It drifted in, moving as everything moves, on its long, slow orbit around the galactic center, passing through regions of the galaxy with varying densities over millions of years. We live in the aftermath of catastrophe, in the quiet left behind by things that burned out before any eye existed to observe them. The clearing they made has lasted this long. We arrived after the violence had finished and found it still here. The Milky Way's disk is warped, and the warp took until recently to map. The Milky Way is not a flat, uniform disk of stars. It has spiral arms, regions of denser star formation rotating around a galactic center. The Sun sits in a minor spur called the Orion Cygnus Arm, not a major arm, a structure between larger ones. The galactic center is approximately 26,000 light-years away. The Sun takes roughly 225 million years to complete one orbit around it. This unit has a name, a galactic year. The last time the Sun occupied its current position in the orbit, the earliest dinosaurs had not yet appeared. The time before that, the first complex multicellular organisms were just emerging. And the disk itself, what we thought of as a flat plane, turned out to be warped. Not flat, curved and asymmetric, bending in a shape that only became clear in recent years as sufficiently detailed maps were assembled from measurements of hundreds of thousands of individual stars. We have been orbiting inside a structure whose shape we couldn't fully see until we had enough data points to assemble it from within. The shape was always there. We just couldn't see it from where we were standing. There are stars so old they contain elements that didn't exist when they formed. There were stars, called Population 3 stars, that existed in the very early universe, before most heavy elements had been forged. Stars made almost entirely of hydrogen and helium, the only elements that existed after the Big Bang. No carbon, no oxygen, no iron. We have never directly observed one. They are theorized to have been extraordinarily massive, far larger than most stars that form today, burning fast and ending in supernovae that seeded the universe with the first heavy elements. The first carbon, the first nitrogen, the building blocks from which everything complex would eventually be assembled. We believe they existed because the physics requires them, and because the universe we observe cannot have arrived at its current state without them. There is no path from hydrogen and helium directly to what we see now without that intermediate step of enormous early stars that burned and scattered. But we cannot reach them directly. They are gone. They burned out before any instrument, any civilization, any structure of any complexity existed to observe them. What we see now are the consequences. Stars that contain elements forged in stars that no longer exist. Planets built from that scattered material. Everything downstream from something we cannot find anymore. The origin is unreachable, and every atom of iron in your blood is downstream from it. The light we see from distant galaxies left before Earth existed. The Andromeda Galaxy, the nearest large galaxy to the Milky Way, is approximately 2.537 million light-years away. The light we see when we look at it left that galaxy 2.537 million years ago. At that time on Earth, the genus Homo was just beginning. The first deliberately shaped stone tools were being made. The continents were in approximately their current positions, but the great ice ages had not yet fully oscillated. We are seeing 2.5 million years into the past with the naked eye. Further out, the distances compound. The Hubble Ultra Deep Field, an image taken by pointing the telescope at a small patch of apparently empty sky and leaving it for nearly 12 days, revealed approximately 10,000 galaxies, most of them billions of light years away. Some near the edge of the observable universe, their light traveling 13 billion years to arrive at a mirror we placed in orbit. The observable universe extends approximately 46 billion light years in every direction. Not because that's where space ends. We don't know whether space ends, but because that's as far as light has had time to travel since the universe became transparent to it. Outside that sphere, more universe continues. How much? We cannot say. And the light from there is still on its way. The great void is quieter than we expected. Between galaxy clusters, there are voids, not empty in the everyday sense. No volume of space is truly empty, but regions where the density of matter falls so low that the familiar structures of the universe, stars, galaxies, clusters, essentially disappear. One of the largest known, the Boat's void, is roughly 330 million light-years across. If our solar system were located near its center, we might not have known other galaxies existed for much longer. The nearest galaxies would have been so distant as to be invisible to early instruments. The sky, even to careful observers, would have appeared to contain only our own. Inside the Boat's void, there are a few dozen galaxies. Against the backdrop of the void's sheer scale, this is close to nothing. We don't fully understand how voids form. We think the large-scale distribution of dark matter, which we cannot observe directly, creates a structure of filaments and nodes, and that voids are what remains between them. But the details of how voids grow to the sizes we observe remain incomplete. What we know, they exist. They are enormous. They are quieter than the models predicted. Why quieter exactly? We're still working on that. Gravity is the weakest force and the one that shapes everything. Hold a small magnet near a paperclip and the magnet wins. The entire mass of the Earth, 6 trillion kilograms, exerting a force continuously downward, is overridden by the magnetism of a small piece of iron. This is not a metaphor, this is a measurement. Gravity is the weakest of the 4 fundamental forces, weaker than electromagnetism by a factor of roughly 10 to the power of 36, weaker than the strong nuclear force by even more. And yet, gravity has no limit of range. Electromagnetism requires charged particles. The strong nuclear force operates only at the scale of atomic nuclei. Gravity reaches everywhere, across any distance, between any 2 objects that have mass. Given enough mass and enough time, gravity accumulates what it cannot overpower quickly. Stars, galaxies, clusters, superclusters, the cosmic web itself, a largest scale structure in the universe, is shaped almost entirely by the weakest force in existence. Patient doesn't begin to describe it. Given billions of years, the weakest thing shapes the largest things. The observable universe has a center that is everywhere. The universe has no center. Or rather, every point in the universe is the center, depending on where you're standing. This is not a philosophical observation. It is a geometric consequence of how the universe expands. The expansion is not occurring from a single point outward, not like a detonation with a location. It is occurring everywhere at once, in all directions, uniformly. Every galaxy is moving away from every other galaxy. An observer in any galaxy, looking out, would see the same thing. Other galaxies receding in all directions at speeds proportional to their distance. From here, from this room, the observable universe extends about 46 billion light-years in every direction. From a galaxy at the edge of our observable universe, their observable sphere extends 46 billion light-years in every direction, most of which overlaps with ours, some of which does not. There are regions of the universe that will never be visible from Earth, not because they are hidden, because the space between us and them is expanding faster than light can cross it. Those regions exist. They will never enter our observable sphere. We are not at the center of everything. We are at the center of what we can see, which is a very different thing. Dark matter has been weighed, but never touched. Something is holding the galaxies together. When astronomers measure the rotation of spiral galaxies, how fast stars orbit around the galactic center, the numbers don't match the visible mass. Stars at the outer edges of galaxies orbit too fast. By Newton's equations, applied to the mass we can see, they should have been flung outward long ago. They haven't been. The best explanation the data supports: there is more mass than we can see. Mass distributed in a halo around galaxies, not emitting light, not absorbing it, not interacting electromagnetically with anything we can currently detect. Present only gravitationally. We call it dark matter. We don't know what it is. It constitutes approximately 27% of the universe's total mass energy content. Ordinary matter, everything you can see, touch, measure, burn, dissolve. The remaining 68% is something called dark energy, which is expanding the universe, and which we understand even less. So, roughly 5% of the universe is made of what we're made of and can interact with. The rest is inferred from behavior. We live inside something we cannot see. That is the current state of the field. Time near a black hole moves differently than time here. General relativity predicts, and experiments have confirmed, that gravity slows time. Not in terms of how time feels, not as perception. Literally, a clock in a stronger gravitational field ticks more slowly than an identical clock in a weaker one. GPS satellites, orbiting far enough above Earth's surface that they experience slightly weaker gravity, have their onboard clocks adjusted to account for this. Without the correction, positioning errors would accumulate at roughly 11 kilometers per day. Near a black hole, where gravity is intense enough that nothing, not even light, escapes, this effect becomes extreme. At the event horizon of a stellar mass black hole, time slows toward a halt relative to a distant observer. Someone falling inward might not notice anything unusual in their own experience, but to someone watching from far away, they appear to freeze, slowing, dimming, never quite crossing the threshold. The Milky Way is estimated to contain roughly 100 million stellar mass black holes. Each one a point in space where time behaves differently than it does here. In this room, in this moment, time is moving at a rate specific to this elevation, this latitude, this distance from the sun, different from the rate at the top of a mountain, different from the rate at the bottom of a mine. Always particular to where you are, always moving at exactly the rate it moves here. The cosmic background radiation is the oldest light we can see. The cosmic microwave background is light, old light, light released approximately 380,000 years after the Big Bang, when the universe cooled enough for electrons and protons to combine into neutral hydrogen, and photons were able to travel freely for the first time. Before that moment, the universe was opaque, too dense and hot for light to pass through. After it, the photons streamed outward. They have been traveling ever since. We detect them today as microwaves, their wavelengths stretched by 13.8 billion years of universal expansion from what they originally were. The temperature they correspond to is 2.725 Kelvin, just barely above absolute zero. The cosmic background radiation fills all of space uniformly. It arrives from every direction. On analog televisions receiving no signal, a small fraction of the static, perhaps 1%, is cosmic microwave background. Photons that left the early universe and arrived at an antenna. The oldest light that can reach us, arriving everywhere, continuously. We are moving towards something we cannot see. The Milky Way, together with Andromeda and dozens of other galaxies in the local group, is being pulled towards something called the Great Attractor. We cannot directly observe it. It lies in the direction of the Centaurus and Norma constellations, a region of the sky that happens to sit behind the disk of our own galaxy, obscured by 26,000 light-years of gas and dust. Astronomers call this the zone of avoidance. What lies behind it, approximately 250 million light-years away, appears to be an enormous concentration of mass. Multiple galaxy superclusters, perhaps centered on the Shapley supercluster. Everything in this part of the universe, our galaxy, Andromeda, the entire local group, is moving toward this concentration at roughly 600 kilometers per second relative to the reference frame of the cosmic background radiation. We didn't choose it. We didn't aim for it. We are being drawn towards something we cannot fully observe, at a speed that registers as nothing within a single human lifetime. We don't know exactly what is there. We won't arrive in any time scale that has meaning for biology. But the motion continues, patient and indifferent, regardless. The sun has already lived through roughly half its life. The sun is approximately 4.6 billion years old. It has fuel for roughly another 5 billion years. Then, as hydrogen in the core runs low, the fusion process will migrate outward into a surrounding shell, and the sun will expand, slowly, over hundreds of millions of years, into a red giant. At maximum extent, it may reach the orbit of Earth. Whether Earth itself survives this is debated. As the sun swells, it will shed mass, and the planet's orbits will shift outward in response. Earth may drift far enough to avoid being consumed, or it may not. After the red giant phase, the outer layers will be expelled in concentric shells of glowing gas and dust, what astronomers observe around distant dying stars and call planetary nebula. The remaining core will persist, a white dwarf, roughly the size of Earth, containing most of the sun's remaining mass. Dense, slowly cooling over billions of years. White dwarfs cool indefinitely. The universe is not yet old enough for any white dwarf to have cooled completely. The theoretical endpoint, called a black dwarf, does not yet exist anywhere. The universe hasn't had time to produce one. The sun's eventual remnants will continue to cool for longer than the universe has currently been in existence. What we call daylight is the middle of that story. The silence of space is a consequence of chemistry. Sound requires a medium. Vibration moves through molecules, air, water, metal, bone, by pushing and pulling them in waves. The experience of hearing is the body's translation of that movement into something it can use. Space is not perfectly empty, but it is far too sparse for sound to propagate in any way that would register as hearing. This means the sun is erupting continuously in explosions of plasma on a scale that would be catastrophic if translated into sound at any distance. Coronal mass ejections, solar flares, magnetic reconnection events releasing energy equivalent to billions of nuclear detonations. All of it in complete silence from where we stand. Jupiter's magnetic interactions with its moons produce radio emissions. Translated into audio by researchers, they sound like something between wind and deep water, between music and static. But this is a conversion, not a direct experience of something the universe produces as sound. The supernova that carved the local bubble, the collapse of stars into black holes, the slow, vast collision of galaxy clusters, every violent event in the 13.8 billion years of this universe's history, in silence. The violence that assembled this solar system happened without a sound that any ear will ever hear. What remains is structure, chemistry, light, arriving quietly. We've drifted a long way tonight. From the moon, pulling gently at the water in your body with a force older than any coastline, past the planets, past the asteroid belt's quiet emptiness, through Saturn's improbably light rings and Uranus rolling sideways through its long orbit, out past Neptune, found by logic before it was found by sight, through Pluto's breathing atmosphere, into the Kuiper Belt's museum of ice, past the heliopause, into interstellar space, along the path of a golden record still moving through a silence it will never leave, into the local neighborhood hollowed by ancient fire, and then further, into the deep structure of a universe expanding, pulling, mostly dark, mostly unknown, and vast beyond any image the mind can hold without letting go. All of it is ours, not in the sense of possession, in the sense of membership. The iron in your blood was forged in a star that finished its life before this solar system formed. The oxygen in your lungs was scattered by a supernova into the interstellar medium, gathered by gravity, concentrated by chemistry, eventually drawn into the atmosphere of this particular planet. The carbon in every living thing you have ever touched has been inside at least one stellar interior. All of it assembled over billions of years into something that now lies in a bed, on a planet, inside a bubble carved by ancient explosions, orbiting a middle-aged star in a minor arm of a spiral galaxy, being drawn toward a vast concentration of mass it will never reach. That is what is happening right now, even as the breath slows, even as sleep begins to take you. If your eyes feel heavy, let them close. The journey doesn't require you to stay awake. This is exactly where it was always going. If this felt like home, leave a comment when you wake up. It matters. Every voice here makes this something we're building together. If you're still here, the next chapter is waiting. The universe will still be here when you wake up. So will we. Good night.